All right. So, in the first part of the lecture on transparency, we talked about primarily the some introduction on what transparency was, what is the difference between carrying on live transparency and flattening, and we also saw the different types of transparency blend space that we have in InDesign, and as well as we saw what are the different types of transparency groups that we are allowed to create and the effect it has in terms of how they interact with the background, how those groups interact with the background. So primarily these things we uh, you know discussed, and we saw some demonstration as well. In this part of the lecture, this will be the second and the last part on the lecture, we will be discussing on the flattening process. We'll be seeing what is the how flattening is done. We'll be seeing some demonstration also, and we'll be talking about what is the difference between flattening and rendering, as you can see in front of you. And furthermore, we'll also see some of the advantages of rendering instead of flattening, and how flattening is done in different for different types of objects, be it your colors, spot colors, be it your overprints, like that. So these things we will be discussing in this part of the lecture. Now, quite simply put, as you can see in front of you, that when you are talking about the differences between flattening and rendering, flattening is something that you need to do if you are using PDFX1A standard for exporting your uh, uh, PDFs or creating your PDFs from native applications, because live transparency is not allowed in, or not supported rather, in your PDF 1.3 version. So you cannot create live transparency, you cannot use live transparency. So what does flattening mean, right? So, and what are the materials, or what are the objects or the effects, most importantly, that are flattened? So you see this text, graphics, image, mask, soft mask, layers, spot colors, overprint, all these things, and special effects like drop shadow, all these materials, all these effects basically come or fall under the category of being flattened whenever we're exporting some file, exporting the PDF based on PDFX1A standard. Okay, but ultimately, what is the aim of flattening? Aim of flattening is to ensure that the visual effect that you are looking for in the final PDF. Suppose you have, in earlier case I showed you that what is that your drop shadow. So a drop shadow is an effect. Maybe you reduce some opacity of some object just to give to give it a overprint type of a appearance, so that objects beneath it may interact with the objects on top of it. So these type of visual effects, when we are doing or adding in some design and creating some PDF, flattening enables us or helps us to preserve that appearance, that visual appearance, even if our PDF file does not support it, or if the PDF format does not support it. So that is what flattening is. Now the question is, how does flattening and ripping or rendering uh, differ? I mean, I should not say ripping, because ripping is a entire process altogether, but how does flattening, better to say it in this way, that what is the difference between flattening the transparency and then and as opposed to using live transparency to render the file, or rendering the file that, for that purpose. What is the difference? You see, why do we sometimes prefer, not sometimes, I would say, given a choice to us, that whether we will be working with live transparency or not, of course we will be choosing live transparency. There is a reason behind it. Flattening, for all intents and purposes, that is done at flattener configuration, which is set of a specific at a specific resolution. So let me go ahead and show you. I'll talk about this file in a bit, but when you want to flatten the your appearance, then flatten the file actually before exporting it to PDF1x PDFX1A format. Here you will see that these are the presets that is given basically in your native applications. So what is the highest resolution that is available for raster or vector artwork? It is 100, right? And for your line art and text resolution is 1200 ppi, gradient and mesh resolution is 300 ppi. So this is the maximum resolution at which you can render or you can flatten the artwork if there is light transparency in your artwork at all. Okay, so you are kind of, you can say, you are limited at your, what to say, the maximum resolution at which you can flatten the artwork. But when you are capable of using live transparency in your PDF, then ultimately that transparency is being rendered by your RIP engine. When you are sending your final PDF to the RIP engine, then at the RIP, your transparency is being rendered. Here comes the interesting point. You see, when you are rendering the transparency and you have worked with live transparency, there is live transparency in your PDF file, and you have sent it to your RIP station and it is getting rendered. So what is the resolution at which the RIP will render your file or it will create plates? It is, for example, a resolution of this much, 2540 ppi. Normally our work you can do in 2000 ppi, 2400 ppi, like this we can do a 2540 ppi, all this. So ultimately what I'm trying to say over here is that when you are using live transparency and you are using the RIP, or you are, rendering the transparency in your RIP, then the addressable resolution is quite high. The resolution at which the transparency is being rendered by your RIP is very high. Is your this value, whatever it is, 2400 ppi, 3200 ppi, whatever the value is, that is the maximum maximum addressable resolution, or maximum amount of resolution which your device is capable of handling. So your transparency is being rendered at that highest resolution. So naturally, the effect that you see, the visual effect of preserving that transparency, that will be done in a much better way because your ultimate addressable resolution is quite high, is it not? So this is what I am trying to explain over here. What is the advantage of going for rendering your transparency at the RIP station? What is that advantage that I am trying to explain over here? Okay. The problem with flattening your transparency at your native application stage is that you are limited in your maximum resolution at which your transparency will be flattened or will be rendered. But when you are doing the same thing at your RIP, then you have a much higher resolution at which you are able to render your transparency. So that is the primary reason why the introduction of live transparency was so important from PDF 1.4 onward, and why we prefer to use live transparency in our PDF files. In another lecture you will see, I have told you, I mean, you cannot compare this, but just trying to draw an analogy. When you might hear sometimes, because in the GWG workflow also they have also recommended there that use of media neutral color spaces or media neutral workflow to create your PDF. That means ICC based RGB should be, or device RGB should be used for creation of your PDF files, or the images that you use. It is recommended that they either have ICC based RGB or your device RGB color spaces. What is the advantage of that? That I have explained in that workflow lecture although, but I'm just trying to draw the analogy over here. Intention there, when you are using this type of workflow, is known as media neutral, because you are not preparing your PDF to be printed with a specific output intent in your mind. That is why I'm saying. So when you have got your embedded RGB profiles for the device, for the images that is in the PDF file, then ultimately you can render that file for any output intent as you may wish. So this enhances the life cycle of the file. I mean, principally, this process of rendering your transparencies at during RIP and not flattening them is also, I mean, quite similar. Principally, not, they're not the same thing, but I'm saying principally they are similar. Why? Because our intention is to get the best output possible, which we are able to do at the RIP, because we are able to render those files, those transparencies, at a much higher resolution than what we are able to get during flattening the transparency at the native application stage. You saw I showed you maximum resolution for text and this line artwork is 1200 ppi. So we are limited in the how much amount of uh, maximum resolution we are able to get. That is the issue. Okay. Now let us understand that what ultimately happens during flattening of the PDF. Two things we'll study now. One is the flattening process, and the next is what are the transparencies that we are talking about. And in the end, we will see some demonstration, and following which we will be using some. We will be seeing what are some of the best practices in rendering these transparencies. Okay. So see, the process of flattening converts all objects that are interacting with each other, that are present in a specific stack. Stack means that the PDF is object oriented. So all the objects that are present within the PDF, they are arranged like I showed you in the earlier lecture also, in the part 1 lecture also, that how that magenta background was present at the top of the stack. But there was actually a uh, uh, I mean, in the sense that there was a problem there, because it won't impact really, but just I would like to point out, if you remember that stack earlier that I showed you while talking about the transparency groups, you saw there was a magenta background. Actually, see, magenta background was at the top of the stack of all the objects in the PDF, but magenta is to be printed first, so in that sense it should be in the bottom, right? But because we are seeing it in an object level, I mean, objects of all the there is in the PDF, that is why it was present in the top. So in this context, flattening means any object which is interacting with each other, right? That those objects actually, those objects are converted in such a way that the overall visual appearance of the object is maintained. I will show you some examples also to explain what I mean by this. So in what are the things that in flattening operation does to any file when there are objects which are interacting with each other in some way or the other? First, it cuts the transparent artwork apart and represents the overlapping transparent region by individual abutting elements, each with its own color. So I will show you one example where this becomes very much clear, that if there are multiple objects in a particular artwork, all the entire artwork will be divided into small components, right? And then each of the component will be rendered separately with its own separate color, right? It's quite interesting in that way. Second thing that it does, this flattening does, is it retains the integrity of the original transparent object as much as possible, that is type, shape, etc. But it may rasterize some type or artwork when necessary based on the file's complexity, and the flattener settings in effect at the fact that it sets the resolution of rasterized areas to a specific device dependent value that is defined by the flattener setting at the time, that I already showed you, that what are the presets that are available. So these things I already showed you. Let me just go to that thing and to the software, and let me show it once again. So if you go to the preset, so this is the normal 3 presets that are already available to you. This is built into the native application. This is what the GWG preset is. Okay, in this GWG preset you will see the raster vector artwork is balance is 100, right? The line art and text resolution is rendered at 2400 ppi, and the gradient is rendered at 600. So this is ultimately greater than what is the high resolution preset available in InDesign, but GWG provides a higher resolution preset at which the value, I mean, which the flattener will work and flatten the various transparencies. And the final thing it does, the software does, is if overprinting is also used in the file, the flattener by default may process this overprinting object as it would process overlapping transparent object. Okay, so why is this quite important for us to understand over here? That suppose you remember that black text on the magenta area. So see, the that black text was in a transparent group, Okay, even if it is not in a transparent group, during flattening, these objects, that is the background and the black text which is overprinting, both of them will be considered as overlapping transparent object, and then you will find the resultant output. Why? I mean, what is the effect that it will have? You will see that this impact that overprinting normally has, any two objects which are getting overprinted, maybe magenta is getting overprinted on cyan, that blue coloration, the dark blue coloration, when you are using a overprint fill option, when you are selecting the overprint fill option and you are rendering, or ultimately you are basically flattening that file, that that entire area. So let me just go ahead and show you one thing. So I'll just create a new document to explain this process a little bit actually. So let me build the same thing. Okay, and two other things, right? Two boxes that I have built now. So let me add one color over here. This is cyan, right? And this is your magenta. This is the process colors only, right? Okay, so now what I'm going to do is I am going to add overprint fill in this and switch on the separation preview. So what ultimately happens, if I am able to draw this, let me just minimize, I mean reduce the size. So this is what the object is going to look like after it is getting flattened. Okay, but what happens in the background is what this flattener will do. It will actually going, it is going to create three objects in this image. In front of you, you see two objects. What are these two objects? This blue, I mean cyan block, and the magenta block. But after flattening, what is going to happen is you will be able to see three blocks: the cyan block, magenta block, and this area where they are both overlapping with each other, that is overprinting is happening. This area will be rendered separately. This area will be rendered separately. Okay, so this is, I have a picture also to explain here. See this picture. So see here, there is overlapping, there is overprinting going on, right? What after flattening, what is being done, you see this, all these areas are imaged separately. All these areas are imaged separately. So this area where the waves are crashing onto the lighthouse, this greenish area, this will be imaged separately. This blue wave on the with the sky background, this will be imaged separately. And of course the rest of the lighthouse and the sky, they will be imaged separately, because if there is some overlapping, there is some overprinting, so this will also be treated as a transparency. See, try to understand the concept over here. See, here I have not changed the opacity of any of the objects. So you will say, sir, why you are saying this is transparency? I am saying it is not transparency. I am saying it will be treated as a transparency. Why? Because there is overprinting involved. So that is what I was saying, that any over, although there is no transparency per se, even if they're overlapping or overprinting on one another, that will be considered as a transparency, and that will be rendered separately. Those objects will be divided into various zones, and that will be I mean addressed separately or imaged separately. Okay, that is a very important point over here. Now here this list is providing you what are the sources of which thing you can call as transparency. What are, if there are certain elements you are using in your various objects, and how there are some interactions between those objects, what are the elements or what are the effects that will account for that transparency, or what will be considered as transparency. Okay, so objects that are a source of transparency or interact with transparency are processed by the transparency flattener, possibly resulting in changes to their composition in the output that I have already mentioned. So the following are the uh, uh, you know elements or design concepts where, which will be considered as transparency for flattening the so if you are using a blending mode, as I showed you over here, that opacity is less than 100. So let us change the opacity over here. If the we are using an opacity of say less than 100, so naturally there is this kind of a interaction between both the objects, and this will also lead to transparency. Another thing is that if you are here, the blending mode that we have chosen, that was normal, right? So I switched off the overprint just to show you. Blending mode is normal. Now if we select any one of the blending mode which is not normal, apart from normal, let us say multiply, so this will also result in that appearance of that interaction between the two objects will be apparent, and this will also be treated as a source of transparency and it will be flattened. Next is opacity mask is used. Other is drop shadow is used if you are using that effect. Inner glow, any. So this inner glow, all these things you can easily find out. So under the effects, and you can use the drop shadow. So if you are using a particular drop shadow, so this will also be another type of transparency that will be considered for flattening, right? Inner glow is also one of the thing. It's a fill or stroke has a if a fill or stroke has a file has a style, brush, pattern, or filter effect that has any of the previous properties. In that situation, it is placed image Photoshop file with a transparent background. So I will show you this a file with a transparent background only. It is a placed graphic Illustrator file, native or PDF, that contains one or more objects with any of the previous properties. An object interacts with transparency if it is the source of transparency, it is overlapped with it is very close to a source of transparency, and beneath it in the stacking order. So in all of these situations, you will say you will find out that all these objects will get flattened. I mean, if you are using a flattener, obviously, but ultimately all these elements, if they are being used, or this design you know uh, ideas are being used on the objects, then these are the sources of transparency in your file. And depending on whether you want to flatten it or not, that is a separate issue, but these are the sources of transparency. Okay, so this is then, now here we come to flattening. So this, don't think that I have crisscrossed this component of this part of the picture. This is has been automatically done by the flattener mechanism. So here you will be able to understand how the flattening is actually done. So this is one patch that I have taken from the Ghent Workgroup suite, that is also available in the, as you can see, that is also available in this particular website. You can download it. It is free to download. Okay, so how is the flattening actually done? Now, wherever there is some flattening, you see, so there is wherever there are transparencies, I'm sorry, so there is some soft mask that is being used against some background in these text objects. So these are the sources of transparency. So how these transparencies are being treated by during the flattening processes, they are broken down into smaller chunks. These are known as atomic zones. Okay, and if there is any sort of transparency effect, so all of those things that I referred to in the earlier slide, all those components are broken down into smaller areas or smaller regions. These are known as the atomic zones, and each of the atomic zone stands on its own, and they do not rely on the underlying or the overlying object in order to determine its final appearance. So the appearance of the or rendering of individual atomic element is decided by the flattener software. This does not depend on what object is beneath it or what object is above it in the stack, but it is completely determined on the final appearance, on the fact that the final appearance of the image should be similar to that of the original. Okay, and there is sometimes you can see, I will show you that the stitch between atomic zones can sometimes show up on screen, and as very thin white lines. That has happened in one of my files that I have created. And you can switch off this. You can turn this off by turning off the smoothing, that is the anti-aliasing option, when you go to the preferences in the preference section of the software that you are viewing the file with. Okay, next, now we are talking about specific issues. That is, we are talking about how the flattening is done on overprint, and then we'll see some spot colors and other effects also. See, if overprinting is mixed with transparency flattening, this can cause overprinting to be pre-processed in areas where both overprinting and transparencies are applied. When there are two, then overprinting will be first process, and then the rest where there is overprinting and transparency is applied, both are applied together, that will be processed. This following list contains conditions under which the flattener pre-processes overprinting instructions. What are those? Overprinting objects have transparency applied directly to them. So for example, they are less than 100% opaque. So these are the source. Overprinting objects are part of a group to which transparency is applied. So like I showed you in my earlier file, so that there was a black overprint, and it was part of a group which was a transparency group. Overprinting objects overlap, that is, sit underneath and are within approximately 1 point of object or groups that are transparent. So very close to the object that is transparent. Overprinting objects are in placed file to which some transparency has been applied. So like the earlier discussion we had, that when we are placing some objects, linking some object which is having some transparency in some other, maybe we have prepared that in Illustrator or in Photoshop, and we are adding that image in InDesign, there is original, I mean there is transparency in the original file, so that transparency is also being brought over here. Overprinting objects are part of a complex region that the flattener must rasterize. These are the conditions in which the flattener pre-processes the overprinting part. That means first the overprinting will be done, and then the overprinting and transparency, that both will be applied. Okay, the flattening will be done. If an overprinted object is involved in transparency, overprint is flattened. That is, overprinted object is divided into atomic zones and their color is flattened, taking overprint into account. Flattening of overprinting maintains the visual appearance of the object involved, and in it separates correctly. In other scenarios, overprint instructions can be generated as a result of flattening, even if no overprint is set manually. This can happen when spot colors that are involved in transparency are flattened. So these all examples I'm going to show you in a bit, right? So this last part is quite important. Here it is said that overprint instructions can be generated as a result of flattening, even if you have not set some overprint. Where it can happen? When there are some spot colors that is involved in the transparency. So that I will show you. Next, never use RIP's discard overprint option when dealing with transparency. So that will result in a disastrous appearance. It will not match with the original. Okay. So next comes our topic of how the spot colors are basically flattened. In some cases, when spot colors are involved in transparency, flattening relies on overprinting to render the proper result. Some blend modes cannot be applied to spot colors, in which case normal is implicitly used instead. So when, like in this particular example, these are two process colors only. So let us say that one of them were spot colors, and I applied a blend mode which is not normal, maybe which is multiply or something like that. In those situations, what we can say is that that specific blend mode will be discarded and normal blending mode will be selected automatically. Okay. Next is font conversion during flattening. This is also another important part. If text is involved in transparency, flattener often needs to rasterize or outline some of the characters in the text. Because the flattener only flattens text in areas affected by transparency, it's possible that some characters will be flattened while others remain unaffected. In this case, what is the recommendation? That wherever possible, place text and the line art elements above all nearby sources of transparency in the object stack to minimize the possibility that the flattener will process them. So that this partial flattening of the text does not happen. Whenever you are placing the text, it should be placed near, all these sources should be placed in the object stack of the transparency object stack, so that it does not, the flattener will there's a minimum chance of the flattener processing these fonts or these line art or text matters. Okay. So now, as we have already started this discussion earlier also, that what are the, so this went about, we talked about the flattening process, right? How flattening is done and all this. Now here we will be talking about what are the advantages of live transparency. Of course, transparency, if you are using live transparencies, quality will be higher because you are imaging at a very high resolution. Transparency effects are directly rendered at output device addressable resolution. No object clipping is done, no image clipping is done. Like object clipping means this type of effects, that because I told you the entire object is clipped into different parts, like this one, this entire image and the individual objects are divided into sub parts. So this clipping and this object separation, these are not done when you are using, or when you are basically working with final or working with live transparencies basically. And ability to edit is preserved. Yes, whenever you are using live transparency option in your, if your PDF is file is capable of handling live transparency, you can edit in that file as well. No unnecessary object conversion, that is outline text that I told just while back, that when it is text is very close to your this thing transparency, then some part of the text which is close to the transparency will get converted, will get flattened. So that is not happening again. This allows color managed PDFs. Objects can keep their original color space since the file is not flattened to the blending color space. This is again a quite a good advantage, so that the overall longevity of the file is preserved if you are using live transparencies. Spot colors definitions can be maintained till the very end, because spot colors are also not converted and I mean not flattened during the flattening process. Ability to search is preserved, because once your text is converted, I mean flattened, then you are not able to search, that is not searchable in any way. But if you are working with live transparencies, text is not flattened, hence the ability to search through that file is maintained. No flattening issues occur. No viewing issues like the one white lines that appear sometimes, that does not occur. And these result in faster PDF export and smaller files. I will show you because see why smaller files, because the entire image is broken up into small sub images, you can say. I will show you the sub images also. So many components within the image, and all of these images, there is atomic zones, are imaged separately. So naturally the overall size of the file and image data that increases, and that results in increasing the file size as well of the flattened PDF files. Okay, now let us take a look at the demo. So this is the file that I have created. You can find this original file in the webinar that I referred to. So let me first explain the file in itself. So this card object, this object you can see, this is actually a Photoshop file. And if I just open the link, you see this is the Photoshop file actually. Yes, this is the Photoshop file. As you can see, this is having a transparent background. This card file is this object is having a transparent background. Okay, and in the background, the color that you see, this first color is basically magenta color. Okay, this is 100% magenta. If I just maximize this, you will be able to see that this card is in device CMYK color space image, and it has got a transparent background, and it is being overprinted on a 100% magenta background, and the blending mode that you see is also normal blending mode basically. Okay, this is normal blending mode that we have used. You can see over here also that this is a normal blending mode, right? In the bottom image, I have done the same thing. I have placed the same image, but here the background, you can see, if you wish to see, the background contains rhodamine. Okay, the background contains rhodamine. Now if I just remove this, you can see that the background is made out of a rhodamine. This is spot color, Pantone spot color. Okay, now the idea over here is that what I want to do is that this is again a normal blend mode. This is the first page. This document has got 3 pages. In the second page, if I show you the second page, it's just the same thing. The object is also same, the image that is also same. The background over here is 100% magenta on top, and on the bottom this is 100% rhodamine. This is again a spot color, but the difference is, you see, there is a drop shadow in the card that I have applied. If you look closely, there is a drop shadow. You see, this is the drop shadow. So this is again a transparency. So how many transparency objects are there over here? So one is this transparent overprinted I mean object which is with transparent background, that is getting overprinted on the magenta, here in case rhodamine, and this drop shadow is adding another level of transparency. So if you just take a look at the effects, you see the drop shadow is switched on. I'll just show you. See, the drop shadow is switched on here. Okay, this is 100% K drop shadow, right? And in the bottom image also, the drop shadow is applied with the rhodamine background. That's it. This is these two cards. In the third page, you see the background remains the same. This is 100% magenta. This is also 100% this is rhodamine spot color. But the card, the color of the card is now duotone. This color is made out of, I think, again rhodamine. I have made this with rhodamine and black. That is the uh, color that I have chosen. So let me just go and if I can select, I don't know if I can select the car. So yes, so this is the rhodamine file that I have chosen. This is the object. So these are the two objects that I have chosen basically. So here the car is a duotone which is made out with two colors, that is black and rhodamine, right? And the background in this case is 100% magenta. In this case is rhodamine. So this Pantone rhodamine, obviously you understand this Pantone rhodamine spot color, right? And there are no special effects. I mean, no drop shadows or anything in this file as such. Now, one interesting thing that will happen now is when I will export this particular file in two methods. The first method is I will export this file. I will export this file in X1 format. Okay, so this is the PDF X1 format using which I will export the file. So yeah, so let me just change this to PDF X1A 2003, and the remaining should be the same, right? So this is the file that should appear some, yes, this file has appeared, right? This is the file which has got the transparencies effect, but I have exported this as X1 in X1 format. I will do the same thing with the file, but this time I'm going to export it in X4 standard. Okay, so let me quickly go ahead and change this X4 standard. Yes, this is also correct, right? So yeah, right. So this is done. Okay, so X4 standard is also obtained. Now what I'm going to do is I'm going to open both the files. First, before opening, let me just show you the file size, the general file size. See, if I just move my cursor, it should be, just let me check once. Yeah, see the size of the file which is having transparency, which has been exported to X1 is 5.37 MB. Okay, 5.37 MB, and the file which has been exported in X4 standard, that is 2.43 MB. Almost half of the X4 is almost half in size as that of X1. So this, our initial premise that I started with, that is the size of the file of in X1 will be higher because the number of objects will increase in X1. So let us now open the file. Okay, this is the X1 file. Yes, so this is, let me just minimize this once. Yeah, this is I think the X1 file, and this is the X4 file. Let me also open this. Yes, this is the X4 file, right? Now what we are going to do is, first thing that we are going to do is we are going to see the wireframe structure of both the files. Okay, sorry, this one. Yes, so here as well we are going to see the wireframe structure of this file as well. So now see, what is the difference between the wireframe structure? Wireframe structure is showing you what impact flattening has, or how many atomic zones the image is segregated into or separated into, right? So that is what the wireframe structure says. This is the X4 file. On the file that I have got in the right hand side is the X4 file. The file on the left hand side is the X1 file. See, obviously, because we understand that X1, whenever we are exporting the file into X1, even though, see, in InDesign, there is the option to set your transparency set your transparency preset, right? Now, even if you are not selecting the transparency, you are not flattening the transparency using InDesign, automatically when you are exporting the file in X1, it will be, your files will be automatically flattened if you are selecting, if you are selecting it to be exported in X1 format. So ultimately what is happening, the entire image is separated into these small atomic zones. So this is one zone, this is another zone, this is one zone. So the entire image is getting separated into so many atomic zones. So this is for the first page. The second page has got even more atomic zones. So I will come to this. This is a very interesting thing, that second page will have more number of atomic zones than the first page, and even the third page has got these atomic zones over there, right? Now, in contrast to this, the PDFX4 standard does not have these many number of atomic zones. Only in the second page number of zones are higher, but in first and the third page number of zones are quite low. Now the question is, why this has happened? Simple, because the file has been segregated. When creating the X1 file, as I already told, the file has been segregated into smaller components, smaller sub images, and these are the smaller sub images. This is one part of the image, this is one part. I'll show you. All these images together are making up the file. So that means these parts, these components, these individual atomic zones have been imaged or rendered separately. This has got no relation to this component, this has got no relation to this component or this component. Each of them have been imaged or rendered independently. That is why the file size has increased. Now let us take a look at some of the other interesting aspects actually of this X1 file. Okay, so before that, let us just go to let us just take a look at the object stack of the X4 file. Yeah, so this is a very simple, object stack. As you can see, this is very plain and simple. What this image or what this file contains is these many number of objects. So what are these objects? It's very easy to understand. This is the background, this magenta background, this is the rhodamine background, and there are two cars basically, right? There are two cars and two text matters. Okay, so that is what this object, this particular file contains. Okay, now if I simply go ahead and delete this component, right? So this was the rhodamine, I'm sorry. So if I simply delete this, both of them actually, what you can see the car intact. That is, the car is intact and the background has been removed, background has been deleted. So it's quite easily understandable that the car with the transparent background has been overprinted on top of that background. Now if I just go and redo this, I mean undo this, right? And let me just now go ahead and delete the car. So the car has, along with all its components, let me just delete this. What you can see, car is overprinting on top of the background, right? Similarly for this car as well, both the cars, right? So it's quite fair and easy to understand that how these imaging have been done. Very easy actually. Even in the second component, second page actually, if you take a look over here. So let me just go here. So here as well, if I delete this, so just one second. Yeah, so if I now open the object stack, yes, so this should be it, right? So if I delete this, yes, so now if I just select this second page, actually I was not selecting the second page, it was still on the first page itself. So now if I select this second page, if I using the inspect tool, now if I simply go ahead and delete both these things, you can see as soon as I'm selecting this path, you can see this is the background which is going to be deleted. If I delete this, this is the background, but ultimately the effect remains the same. In the second page, what we used, in the second page, the object had got two components, that is the car itself with the transparent background, the background, what was this background is made out of rhodamine, this is made of 100% magenta, as well as the drop shadow. Now the drop shadow is quite interesting to notice. You will see one thing, that now if I go ahead and simply delete this clipped object, and let me delete the next second car actually, this component, right? This component, as you can see, this is made out of a black form, black colored form. This means that this is talking about the drop shadow. If you delete this group, actually the drop shadow effect will be deleted, not the car itself. Let me show you. So this is the drop shadow effect has been deleted. That is why the wireframe actually showed you two kind of boxes, two boxes. Now the for deleting the car, for the purposes of deleting the car, let me just select the second car. If you want to delete the car, then you need to select this clipped object with the image of the car in view. And then if you delete, see, this is the drop shadow effect, that is on which the car was overprinting, and this drop shadow is again overprinting on the rhodamine background. Okay, so here the overprinting, see, as I told you, if you remember that correctly, if the thing that I told you over here, that what situation under what situation, I'll just remove this, under what situation the overprint will be generated fast, if there is spot color involved in the transparency, then overprint instructions will be generated fast, even if there is no instruction, I mean manual instruction of overprinting. That is exactly what has happened over here. This is exactly what has happened. See, the drop shadow is overprinting on the spot color, and if I, on top of which the card is overprinting, right? So you might ask, why is it overprinting? Why is it not a knockout or something? There is a knockout concept also in the X1 that I will show you. But the concept here is that whenever you are overprinting on and there that is involved with a spot color transparency group, then naturally the overprinting will be processed fast, even if I have not explicitly said that there is overprinting involved. Okay, so the second page that I wanted to show, and in the third page it's actually quite interesting. Here, if you take a look at it, so yeah, so this is the object. Simple. This is actually quite similar to the first page. Okay, where if I see, this is defining this duotone image. Okay, and this path is defining. Sorry, this path is defining the background. So if I delete the path, only the background will be deleted. And if I delete the duotone object, that is the car, this grouped object over here, then the entire car will be deleted. No special effect that we will be able to see. But this is quite, very simple to understand, that there is a background and there is an object with a transparent background. The object is overprinting on the background, and this is individual grouped objects. In this case, this in the earlier second page, if you take a look at the second page, there were grouped two objects, that is the car as well as the drop shadow. They were grouped actually, and two separate groups actually. They were overprinting on the background, and if you remove any of those groups, you will be left out with the background, right? If you remove both the groups, that is the drop shadow group as well as the car group, then you will only be left out with the background. So this is quite easy to understand, nothing fancy going on here, because this contains live transparency. Live transparency has been maintained over in this file, X4 file. That is why the file size is also limited. But if you take a look at this file, I want to come to this particular file. See now, see how many objects. Will not be able to even understand how many objects are here. See, in this file, we are only these many objects. Like for the first page, we are only these many objects. But as soon as I select this file, the number of objects has increased many-fold. Within this page, within this document, we have got so many objects to consider. Now this is quite interesting, so I'll just maximize this, okay, so that you are only able to see this and not the remaining. Okay, so if I select this, if I select the path first, okay, if I select this path, let us see what is happening. If I simply delete this, okay, so what is the, so just a second, what is the impact that it had? See, I deleted that path, but you are not able to see what has happened. There is a reason behind it. In the earlier case, whenever we selected that background path and it got deleted, right? This time you are not able to see, because there is not a single background over here. If I click anywhere, I have intentionally not clicked on this image till now, but if I click anywhere, you will be seeing some small boxes appearing, and each of those boxes are those atomic regions that I referred to earlier. Okay, so let me just go ahead and undo that delete option. Yeah, so if I delete this, if I delete either of these things, there will be no effect ultimately. If I select this path or this path, this is the bottom background, this is the top background, this is the magenta background, and this path is the rhodamine background. So if I delete both of these things, let me delete both of these backgrounds, so no effect you will see, because this image, this rendering has been done differently. That is why in the earlier case, if you simply selected the background path and you deleted it, the entire background went off and you are only left out with the car having a transparent background on a white page. That is how it worked. But now let us see how this is imaged. So we have understood that this is a little bit different. This is not really imaged in the same way, right? So this is the total number of objects. Now let me click anywhere. So I'll click outside and I'll click anywhere within this image, right? So see what is the effect. I clicked here in the earlier case, whenever I clicked on this entire image, that particular entire portion of that image, that is the entire top, would have been selected, or the entire bottom would have been selected, right? But in this case, only small components are being. Let me select the inspector. Yes. In this case, only the specific area. See, this is one box, right? This is another box. This is another box. This is another box. If you remember correctly, in when I tried to show you the wireframe, take a look at the wireframe once again. Take a look. So this is that box, right? This is what we have selected just now, right now. So this is that image. The first image that we selected was, I think, this one. We are not able to select it. Okay, let me go back, return. So this is the image that this is the component of the image of the atomic region that we selected first. So this is this component, this bigger, longer component, right? So one thing is clear to us, that the entire image has been broken down into smaller components. Now, if I delete this individual images over here, what is going to happen? See. So what happened? That area, that atomic zone contained this front portion of that front wheel of the car. Okay. Now, if I select any specific area, let us say, which area should I select? Yes, let us say, let me select this particular area, okay, in this component, right? Or I can select a similar object here also on the top image as well. Let me select, yeah. So this is the component which I have selected now. So if I delete this, what is going to happen? This component, this entire thing containing the this part of the car, the back window of the car, that will get removed. If I delete this got removed. But here you see, still you are able to see the magenta background. Now the question is, why you are able to see the magenta background? If I go ahead and delete this, now you are not able to see the magenta background. The first step that I did, ultimately, so what is happening? There is a magenta background on top of which there is these smaller components. If I delete this, here also nothing. If I delete this, nothing. So on top of this, the car has been broken down into smaller atomic zones, and those atomic zones are imaged on top of that background, right? So this is how this imaging has been done. So let me just undo all the changes that I did. Yeah, so this is it, right? Another interesting thing I'm going to show to you that I talked about over here. So this particular part of the image, see what happens if I simply delete this component. See what is happening. This is a magenta area. I mean, this background is magenta, right? So if I delete this, I have deleted the same areas from both the things. So what is the difference that has happened? What is the difference here? Try to think about it for a minute. Why in this area the car part has been removed, and in this area the rhodamine background has been removed? What is that thing that is happening, or that is getting, different over here? See, again, that this component, this line I would remind you of, that in other scenarios overprint instructions can be generated as a result of flattening, even if no overprint is set manually. This can happen when spot colors that are involved in transparency are flattened, right? So this is a spot color which has been flattened. Here we have not set the overprint manually. So naturally what would have happened, that this area is should have actually, in this particular case, this area would have been, the car would have been overprinted on top of that background, right? This is exactly what is happening in the top image, because the background is magenta. But in this case, the background is made out of a spot color. So there is a spot color involved in your transparency group, where there is some overprinting going on. So what is happening essentially is this part of the thing that I wait. Let me just redo this, undo this. Okay, so this part of the background is overprinting with a hollow shape. If you take a very close look at this, I don't know if you can see it nicely or not, just zoom in if possible. See, this is the component, right? This is the image that we just deleted. Take a look at the shape of the image. This image shape is just like this component and a little bit of this component. In the middle, everything is blank. That means what? This is overprinting. This area is overprinting the car. This area meaning that spot color is there. This spot color area is overprinting. If it is not overprinting, if it was not overprinting, then this would have happened. The thing that had happened over here. If I delete this, then the background would have appeared. But in this case, if I delete this component, the entire background, the spot color background is getting removed because it is overprinting with this type of a knockout. This is quite interesting here to understand actually. So let me just undo both the things. Furthermore, another thing I would like to say over here. See, this component is overprinting. This part of this image is overprinting. So now, if we want to take a look at what is going to happen, what the image is going to look like, this part of the image is going to look like if we are converting this from, see, this is being overprinting. If we convert this from overprint to knockout, what is going to happen? See, this is what is happening. Previously, when it was overprinting, this area of this entire area of the car was blank in the original image. But knockout means what? Any area which is beneath it will be removed. So that area that means the car is beneath this spot color, right? So that car area is being removed. Try to understand this concept very well because these are very interesting, important one concept. So the color is a spot color, right? Rhodamine color. Whenever there is spot color involved in your transparency group, there will be overprinting first. Okay, so that is why this your flattener, I mean this flattening software has overprinted this part of the spot color on top of the car. Now you will ask, sir, if there is overprinting on the car, then the color of the car would have changed. Yes, that's a good question. But you see, try to ultimate aim of the flattener is to preserve the visual appearance of the original file. Now, if you say that the flattener, or if the flattener really had overprinted the car, then the appearance of the car or the color of the car would have changed. That is why it created a kind of a hole within this part of the image, such that it is only overprinting in this area, leaving the car alone, and overprinting in this area, right? Now, but if I manually select this to knockout, then knockout means what? On top is the spot color, right? On top is the spot color, below is the car. The car is visible through the overprint. How? Because the overprint itself is leaving this area blank. Now, if I select knockout, the concept of knockout is what? That anything which is beneath it, and that will get removed, and in that area there will be overprint. So exactly this is what is happening. This car area is being removed, right? So that is one important thing that I wanted to mention over here. Now, let us see another interesting thing, that what happens if we convert this spot color to CMYK. So, just a second, yes. So, let us see what happens to the spot color. So, let me just open the output preview once, just to show you that whether this is really rhodamine or something else. Yes, so we have got 4 colors and 1 spot plate, that is rhodamine. So as you can see, this is the entire 100% rhodamine, and these are the spot color. This car is not made out of rhodamine. This is a normal process color, but the background is rhodamine, and this is actually 100% magenta, as you can see in front of you. Okay. Now what I want to do is I want to convert this rhodamine background into CMYK. Now see what happens. Very interesting. See, this background remains rhodamine itself, right? Sorry. So here, see, the background remains rhodamine itself, but in this region, this is not working, I think. What is happening? Yes, just a second. Yes, see, this area is now no longer rhodamine. This was originally rhodamine. This is now no longer rhodamine. This is now been converted into CMYK, because I intentionally converted this particular image into rhodamine, into CMYK from spot color. But this area remains uh, to be rhodamine. Now, here two things I would like to say. Because, see, you might ask that, sir, you converted the CMYK, I mean the rhodamine into CMYK, but what happened to this region? This is still rhodamine. Good question. See, I am selecting, because the entire image has been broken down into smaller sub images. I can select individual areas of the image itself, to edit them, to make some adjustments to them. So when I selected this particular area, so let us say, when I selected this particular area, only this much, the colors of this much area was converted into from spot color to CMYK color. Okay, this much is hopefully clear. Now the question is that why all of a sudden this got knocked out and there is no color over here. Earlier what was happening? Okay, let me just go back and let me just undo this. Yes, earlier what was happening? There was a spot color called rhodamine, which had a hole in the middle, which was overprinting the car, and the hole in the middle was exactly the shape of the car in this area, right? That is what was happening now, and we saw that what knockout effect is. Now what I did was I converted this area, this particular part of the image into CMYK. As soon as I did this, what happened? There was a big knockout over here. No printing here. No image is formed here. Why this has happened? This. If you understand this, you will understand a very important concept in PDFX files. That is on PDF files in general. That is, CMYK can never overprint CMYK. Spot can overprint CMYK, but CMYK can never overprint another CMYK. Initially, what was there? Initially, there was a spot that was overprinting CMYK. But as soon as I converted this into CMYK, so underneath this car was made out of CMYK, and on top of this also CMYK. Now this color is also, as you can see, this is no longer rhodamine. This is also CMYK, right? So one second. Yes, so this is also not rhodamine anymore. This is also now CMYK. So that is why I'm saying that CMYK, this brings in front of us a very important property of PDF files, that is CMYK can never overprint CMYK. Okay, that is why there was this rhodamine background actually in this file. Hopefully this much is clear. Now the question is, can you or can you not edit this? I mean, allow this area to be printed or not? This cannot be left as blank. Yes, you can do that. For doing that, what you need to do is you just need to change the blending mode. Not here, the blending mode was normal, right? So what you need to do is you need to multiply. You need to select the multiply blending mode, and as soon as you select the multiply blending mode, you will get the original. Now it's very interesting is, see, what multiply does is multiply blending mode multiplies the color and converts it into a darker color. So naturally you will see that the color that you see here is not really in this location, is not really the color that you see over here. This is rhodamine, but this is not. But ultimately, since you have chosen multiply blend mode, you are getting this the multiplied version of this car image over here, and ultimately you will be able to see that the appearance will be again correctly set. Okay, so now we have understood this particular concept over here. Now let us go to the next second page. Actually, second page is much more interesting, you see, because why it is interesting? Because there is a drop shadow effect over there. Now as we move on to the second page, over here I hope you will be able, I don't know, but I think if I magnify this enough, you will be able to see some of those white lines. See, this is that line, there is this one line, and there are certain lines I also saw during the exporting the PDF. So yeah, this is another such small white line. So that means what? That these files now basically have got those atomic zones, and ultimately what this means is the image has been broken down and been reproduced by breaking it down first into smaller components, smaller chunks of images, and then joining them together to create the ultimate effect. So now if we so let me just select the objects once again. So if I am able to select it, and then if I am able to view the where is it? Yeah, I am able to view the individual objects. I mean individual atomic zones really. So similarly here also, as you can see that this is that one image. Now if you remove this, sorry, if you not able to move this really, but I should be able to move it. No, I'm not able to. So let me just delete it and I'll show you what this object is. This is very much similar to the first one, right? This is very much similar to the first one. Now you will notice that even in this one, even in this image, there is another effect that we have added, that is the drop shadow effect. Okay, let us see how the impact of drop shadow effect actual or this basically has on the overall image. Now if I go ahead and delete this, so these are other types of other parts of the image. This does not really have much influence on the overall overall way in which the area was imaged. So you see the part of the car as well as the drop shadow is imaged in a single section. But if I select a part of the image over here, you will notice that again, this being that you know the overprinting spot color, you can simply remove the entire thing, and you can no, this I did wrong actually. Yeah, you can remove that entire thing, and you will be left out with the car as well as the drop shadow area. So if you remove all these components as well, uh, yeah, so if you remove, now if you take a look at the part of the car, here you will notice, see, this is quite interesting. This magenta or this rhodamine color that you see in front of you, this is the original background. So if you select this, this is the path, or this is the area which you are looking for. So this is basically imaged first, on top of which everything else is getting imaged. So this is that area, right? In this case also, in this particular context, as you can see that this is again overprinting, that if I just go back to the original state of the image, uh, just a second. Yes, if I go back to this origin, this is that image. If you take a look here in this particular image also, see, this is again overprinting. If you take a look at the what type of overprinting is happening over here, you will notice that, see, this is overprinting, and the nature of the image is that on top and on the bottom there are images which is made out of rhodamine, and within the middle there is this hole in which you can through which you can see the car, but ultimately this is overprinting only. So this is overprinting. This is very much similar to the earlier example that I showed you, right? Now, in the last image, last page that you can see here, I think those thin white lines can be very easily visible. If you see, take a look at, this is the white line, this is another white line, this is another white line. So you can simply go to the preference option and you can reduce this. So these are the thin white lines that I refer to. Now the question is, how is this duotone? We understood how those individual images were present, and how these uh, drop shadow and the car was imaged together. And if you delete this, then ultimately all this is being getting deleted, because these are the atomic zones that were used for making up the entire image. But in case of this duotone, let us see what is happening. Now let's consider this one first. If I delete this part, see what is happening. In the earlier case, if I selected this area, no, not this area, actually this area, if I deleted this entire card would have been, this window part of the back part would have been gone. We will be left out with the background. In this case, that overprinting spot color would be removed. This is, but in the case of the duotone, in both the situations, if you take a notice over here, that in both the cases, two situations are quite different. Let me explain how. You already can understand what happened over here, why the background went off. But basically, one thing is happening which is common to both. See, the black area is now visible, right? So that means what? One thing is very much clear, that because it is a duotone, that this duotone is, again I told you that it is made out of rhodamine and your black. So what is happening essentially is rhodamine is being imaged once and black is imaged in another form. So if the entire image is made out of multiple wireframes, then there is a wireframe for all the one wireframe will be for the black image, and the other wireframe will be for the rhodamine image. So let me just take a look at the wireframe over here. If I can show you, see, there are two wireframes over here. One, so let me just redo all this, undo all this. Yeah. So now let me see the wireframe. Yes, see, there are two wireframes over here which are overlapping on each other. This means if you take a look over here, all these wireframes are doubled, right? So this means what? Each of the wireframe has got, or each of the component of the image is imaging this car in, I mean, twice. Why? Because one uh, part is the made out of rhodamine and the other part is made out of your black. So this is how it is being imaged. Now if I go ahead and delete it, what you will get, you will see this black. Now how do I know this is black? You just open this output preview, and if you just move your cursor over here, you will see that this is pure black. This is only K. You see, this is only K, right? If I undo this, now this was originally only rhodamine and black, right? What happened is, as soon as I delete the rhodamine component, I am left out only with the black layer. Okay, so this is quite interesting for us to understand over here, that in this context, in the earlier cases, this is a little bit different. In the earlier case, because this was made out of CMYK, the car was imaged. The car was imaged in its entirety. At least the part of the car is broken down into smaller areas, but that smaller area is imaged together. That means all the colors are imaged together, right? But in case of your duotone, even the smaller atomic zones that makes up the car, they are imaged separately. That means in one layer there is this rhodamine, and the other atomic zone of the layer is, there is this black. Now if I select this, now you will, this white, I mean black area will be now removed. Okay, so two images are making up the same atomic zone. That is, once there is rhodamine and the other there is black. So two atomic zones or two layers are creating this car over here. Okay, so this is the basic idea. This is true for both of these things. If you delete this, then this is also coming. Now see what happened over here. Let me just undo this, right? Let me just undo this. Why is this area, why is this particular area white over here? What was here? So see, the background is made out of rhodamine. If you take a look at the this thing, output preview, see 100% rhodamine, right? Now this component, this particular area, right, which I deleted, let me select this area first. I will show you in the object browser. So this is the area that I have selected. If you take a notice, if you take a look at the image over here, see, this image is made out of a rhodamine background and the rhodamine part of the car. Rhodamine background and the rhodamine part of the car. Okay, so that is why when I am deleting this part of the image, the rhodamine, 100% rhodamine spot color, right, that is getting deleted, and that rhodamine part of the car, that is also getting deleted. Okay, so as you know that again this is getting over. So let me check whether this is getting overprinted or not. So if I select this, see, this is getting overprinted. If I select this to be knockout, see, this is the effect for a knockout. So that means initially the rhodamine was having two areas. That means this area was 100% rhodamine, and this area, in this area the black was overprinting the sorry, the rhodamine was overprinting the black. But as soon as I turned on knockout, there is only rhodamine effect you can see over here and no black. So this area is completely made out of now rhodamine. If you take a look here also, this area is completely made out of rhodamine. This is no longer a duotone. Initially it was, when it was overprinting, it was rhodamine was overprinting on black. But since I turned off overprint and I turned on knockout, that is why now there is no black in beneath that rhodamine layer. So now you will see this area is no longer a duotone, but this is now only made out of rhodamine. Okay, so this is very fun and interesting things to learn over here. And so now if I go ahead and delete this area, so yeah, if I go ahead and delete this area, so this, because it was overprinting, I deleted the 100% rhodamine and the rhodamine that was overprinting on the black, right? So this is now deleted. Now if I delete this component of this part of the atomic region contains only the black portion of the car. Yeah, I already showed you that this is only made out of black, pure black, right? Now if I delete this as well, this this rhodamine that you see is on the bottom. That is the base actually with which you have made it. Okay, so this is how I mean, these duotones are being handled while flattening the image, right? Now another thing I think I wanted to show. So in this case, the main primary difference. Okay, so let me just once again recap this. Yeah, so the primary difference here is that this component, although is made out of rhodamine and black, but it is imaged differently. There is magenta over here. This is pure magenta. So when I'm deleting this magenta was not overprinting, right? So when I'm deleting this, only this rhodamine part is getting deleted. Magenta is remaining as it is, because since there is no spot color, this is okay, there is no problem in it. This is simply the background on which the car is being printed, but this component was made out of rhodamine, so that rhodamine I am deleting. I am left out with the black. Now here again, if I delete the black, only this part of the component is getting deleted. But that was not the case when I worked with the CMYK car. The CMYK car was made out of only CMYK, no duotones and etc. So if I deleted that part of the CMYK, then the entire component would have been deleted. But that is not the same in case of duotone. This is for magenta background. For your special color, that is spot color background, first if you delete it, the rhodamine is getting deleted both from the this background as well as from the car. You are left out with white. So this white, why? Because it was that rhodamine was overprinting. Now if you convert this overprinting to this is actually, sorry, no, I made a mistake somewhere down the line. So I changed the nature of the overprinting to knockout. Okay, now yeah, so this should work. So this is actually the original state where the rhodamine was overprinting the black, and this is original image was, but in case of the original image, this was a area which had 100% rhodamine, and this is the area where the rhodamine was overprinting on black. Now if I delete this, if I simply delete this, what we are getting, where rhodamine we have deleted, we are left out with only black area, right? Now if I delete this area, you are only left out with the original rhodamine background with which you started, right? So this is what the effect, the various effects of or how the images are getting flattened on using or exporting your files to PDFX1 standard basically. Okay, so that is why the file sizes are increasing. That is why you should be careful about what colors you use, because remember, CMYK does not overprint CMYK, and if you have overprint in spot color, the spot color will be overprinting. That is what has happened over here. That is why we saw that these regions, in this region, the other example, the other first page that we saw, that this particular region was overprinting the car such that there is a big hole in the shape of the car within that patch or within that atomic zone. Top it is printing and bottom it is printing. But as soon as we converted it into knockout, it was, I mean, this part was gone. That means since car was lower layer and rhodamine was top layer, so and we are using a knockout, the car will be gone. No imaging will be done in this. And again, when we converted this rhodamine into CMYK, because CMYK cannot overprint CMYK in PDFs, that is why this area again was gone. And in order to mitigate that problem, although the colors were changed, see the colors have changed already. This is CMYK, this is rhodamine. So when we converted this into CMYK, we used multiply blend mode instead of normal blend mode to mitigate that knockout issue. Okay, so hopefully this much is clear to all of you. Also, since we have seen the duotone in X1, let us also check the duotone in X4 file as well. So for page 1 and 2, I have already shown you, since this is the file that, let us open the object browser. Yeah, so this is the file that we talked about. So if we simply delete this, then ultimately only the car will be deleted. This is true for this also, where we saw that if we are deleting, I mean, in the first page in X4, there was only the car which was overprinting on top of that magenta, I mean, rhodamine or magenta background. And in this case, there are two layers for that matter, two objects basically. One is that drop shadow, and the other is the car. So if you delete this also, you are left out with this. But for the duotone, it's the same thing. Ultimately, it's the same thing. If you take a notice of it, you'll take a look over here. See, there's not something as critical or as difficult of division into at so many atomic zone. One for the this thing your background, one for the overprint spot color, one for the rhodamine tone, and other for the black tone. None of that hassle is there. If you simply take a look at that, this is the duotone color, I mean card on top of the magenta background. So if you simply delete it, the entire thing is gone. And if you, this is also the same, if you simply delete this entire duotone, it will be gone. So no problematic atomic zones and all these things, no critical division of entire image into those zones. So those problems and those I will not say these are problems, but this is a technique, actually very useful technique when we did not have the capacity to work with live transparencies. But that was really critical for any designer, for any prepress operator. It was really critical to understand where the error lied, if there was some error. So that was really critical. But when we started working with live transparencies, the ease of use of these files was very much high, right? So I think we have reached almost the end of the lecture. So yeah, I've already shown you the demonstration. Now another thing that I wanted to tell you is that for pre-flighting with transparency, as you know that PDFX1A did not support live transparency, so all you needed to do was definitely whenever you exported your files containing transparency, you automatically that transparency was flattened. And if you set that transparency to live transparency while exporting that file using the GWG1v4 specification. This I have already discussed in the workflow lecture, so you know that. So this, for whenever you select this GWG1v4 specification, then you will get an error. So let me just show you that where you will get this error. So just a second. If I don't know if I can work with live transparencies, I mean live pre-flight profiles or not. Not over here. I don't see those things over here. So let me go to open Acrobat only. So let us say this is, I think, the X4, right? So what I'll do is I'll check the I'll check the pre-flight. So I'll pre-flight this file with live transparency against PDF1A. Okay, so I will go for spot very high resolution. Okay, and I will check whether there is any error or not. I will run this against GWG 1 specification 1 version 4. That means which is based on this PDFX1A standard, right? So let me run this. See, here it is set to error. Okay, so all these errors you are getting, primarily this error in our case is quite important, that I wanted to show. For the other errors, I mean, that can be discussed later on, but for this context, at least this particular error, the transparent objects have been found, right? So if you select any one of those objects, so all these objects are transparent because this is a car with a transparent background, and this is interacting, most importantly, it is interacting with the background. Then we have got the other object. So this is that object with this image actually, and there are these other objects with the rhodamine background as well. So all of these are getting basically error. We are getting error because this is set to error intentionally. The GWG, when GWG version 1 version 4 specification has been set to error, because if you have transparency in your PDF file, live transparency in your PDF file, and if you're going to save it or work with that file and save it in PDFX1A standard, then you are not allowed to create such a PDF file, right? But you have already created, so you are now pre-flighting it to check whether the file is okay or not. As per okay, as per what? On the basis of what? As per PDF X1A standard. But as you know that X1A standard does not support live transparency, so you are getting that error. But that problem has been mitigated in 2012 and 2015 specification. At least you will not get this error. So let me just go ahead and check this, do this pre-flight based on 2015 uh, spot. Okay, so let me check one thing. So yes, so let me use this profile to check whether we are getting some error. There might be error in the file, but whether it is related to transparency or not, let us check that first. Okay, yeah, so no errors in that respect, no errors in that respect. This is separation related error, so that is a different thing. But no error in that respect, no error in respect of that transparency, right? So this is quite important for us to understand why this is, why we are using different pre-flight profiles, because there are certain things which are allowed in certain versions of PDFX files and which are not. So in order to critically check or analyze those files, we are using these different profiles, right? Next, a very good, so I have already given the demonstration, so that is okay. Now coming to the best practices, where in our workflow, how to set up our workflow in a correct way, so that while getting the output we don't get these type of errors, like maybe we have used transparency where we should not have used transparency, we are over printing CMYK on CMYK when that is not allowed. So these type of, or we have used certain blend modes which is creating some wrong output. So in order to check for those issues, Ghent Workgroup has designed a wonderful compendium, that is the Ghent Output Suite 5.0. As you can see, the free Ghent Output Suite 5.0, which is a, I think, 5 pages document, 5 pages PDF. It does not need to be, it is digitally signed. It does not need to be pre-flighted. All you need to do is to repeat using your workflow. You need to take care of all this software which is used within your workflow to repeat. And then after repeating, if you find out that during the reproduction of that PDF you get cross marks, if there is certain errors, you will get these cross marks. If you have used certain things, maybe you have used ICC based CMYKs, right, instead of device based CMYK, or you have not set, you have set transparency blending mode to RGB instead of CMYK. If you have used, made any sort of mistake within your workflow, if you have set your workflow incorrectly, then immediately what is happened, the file is designed in a such certain way such that there will be cross marks wherever there will be error. Okay, and you will be immediately able to see which area you need to take care of. Maybe you are working with ICC based RGB blend mode, you are working with ICC based CMYK blend mode, you are getting errors in this, these patches are appearing with a cross mark, so that means you have not configured your workflow correctly. So if you use these things, if you use these tools, you will be able to better rectify and point out where the errors are, and you will be able to run your workflow without any hiccups, without any problems, to get the best possible output. That is the whole intention of the Ghent Output Suite 5. Okay, so this is the reference page and everything is provided there, how the images should look like after printing. So you don't even have to print it, you just send it through your RIP server, and through all the workflow, after completion of all the workflow, you send it to the RIP server for ripping. And then once you get the 1 bit diffs, you view it using any first proof or any such software, whatever you are using, or even there are dedicated viewers within your workflow. You view it. If there are any problems, then these patches will not appear. There will be these cross marks will basically appear, and immediately you will be able to understand. You will be able to point out where the error is. So if there's a transparency blend space related error, there is a overprinting related error, spot related error, there is change in output intent related error. So all these errors, each of the patch represents one such area where there might be some error. If one patch is not reproduced correctly or not getting ripped correctly, some cross mark is there or it is not appearing to be correct, then automatically you'll be able to understand and you will be able to configure your workflow properly. Now within the, so this compliancy, in order to set your workflow to to make them compliant with the Gantt output suite 5.0, there are certain recommendations and instructions that are provided by all the major workflow software designers and OEMs, and you can get this data, all these instructions from this particular source that I have cited over here. And I have also hyperlinked all the sites through this. So immediately as soon as you click on these links, all the important instructions will be visible to you. So I'll just show you once. So if you're working with Apogee workflow, then maybe you are working with Apogee 10, then if you simply click this on this link, you will be redirected to the page where Agfa has given the instructions to how to properly configure your workflow to make your workflow compliant with the Gantt output suite 5.0. So yeah, so these are all the instructions that you can see, what you have to do, what are the steps you need to follow, what are the parameters you need to set to what values, and all everything is given. All these instructions are given. If you just simply follow this result, I mean these instructions, you will be very easily able to get the reference output that I have shown over here. This reference file is also attached. I'm sorry, this reference file is also attached with the Gantt output suite folder, which is free to available from this particular site which I have cited. All the documents are that I have used in this particular, all the references that I have used in this document I have cited over here. So you can go to this particular site and download all the necessary files from there. And so this, all the OEMs who are making this workflow software, they have given the instructions quite clearly. So let us say you are working with Harlequin rips. So in that case also, all the companies have provided their respective instructions on how to get successful output with the Gantt output suite 5.0. So this is the instructions from, if you are using Harlequin product. So what are the options that you need to set with images, with step-by-step instructions? Everything has been said over here. Okay, so this was all about this particular lecture. Hopefully, I know both these combined lectures went on for a little bit long time, but I wanted to highlight with especially I wanted to focus on some of the areas where I feel it is important to develop a better understanding of transparency, how they work, flattening of transparencies, working with live transparencies. What's the difference between the two? What you know, uh, really contributes something, some object to be transparent? What is considered to be transparent, right? So all these factors and blending spaces, blending groups, right? All these things I have, uh, elaborated in this lecture. Hopefully, this was an interesting lecture. I have given the demonstration also. So for any questions, you can definitely reach out to me. All right. Thank you for your attention. Thank you for your patience in listening to these lectures. Thank you.